in Google Meet. Record meeting. Okay. So let's repeat this, yeah? Okay. So we are given this task, yeah, that in designing a truss structure, an engineer, so let's assume you are that engineer, finds that the metallic material for a rod should be chosen. So your job is to choose the material, and among these three, it's written there, yeah, steel, aluminum, titanium. According to, so for a rod, should be chosen subject to three constraints. What are the constraints? The rod must support a force of magnitude F. Yeah, it must have length L, and it cannot be. It is not allowed to elongate more than delta L. So it must elongate less than delta L. Among these three materials, which material would you recommend to minimize the rod's weight? Now, minimum weight means low cost. Now, how is area relevant there? Because you know that force divided by area will give me stress, and you already know that stress is what can cause failure. So, for example, stress must be less than the yield strength. Yeah. So area is also important. So if you want to minimize failure, you would go for more area. Why? Because F is fixed. F has been fixed. So more area means that you will have more stress or less stress? Tell me.
Lesser stress.
Less stress. Less stress means that you will be away from failure, okay, from the danger zone. So first we need to now work out the area. Okay. So let's begin this calculation of area. So for area, I need to know, okay, first equation I have in mind is stress equals force divided by area. So that will give me area equals force divided by stress. Now in this equation, I know F, but I don't know sigma. So any idea for sigma? I know sigma divided by strain equals what? The elastic modulus, yeah? So that will give me sigma equals strain times E. Now what is strain? Strain is delta L over L, yeah?
L.
Times E. So now I can simply plug this there. So what should I get? Tell me. You will have F in the numerator. Yeah. You will have this L in the numerator and E times delta L in the denominator. Agreed?
Yes, sir.
So this is the expression for area. Can you tell me whether there is anything unknown here in this expression? Which quantity in this? Huh?
Sir, all these quantities are, sir, unknown.
No. You have to assume that in the question, when say the rod must support a force of F, you assume this is known, yeah? So F is known, yeah? L is known, delta L is known. The only thing that is to be decided is E, because you have not decided the material. E depends on the material. Agreed? So only only E is something which is not clear in this formula. Everything else, and that's why I have encircled it. So now, but in this this calculation is still incomplete because this says nothing about the main quantity. The main quantity to minimize is weight, yeah? So we need to have a
Yes.
formula. We need to have a formula for weight. So can you tell me how do I go from weight to, how do I go from, let's say, area to weight? Because this is a rectangle, this is a cylindrical shape, yeah? So in cylindrical shape, I can multiply area with length and that will give me volume, right?
Yes, sir.
And volume can be multiplied with weight density, not mass density. So I'll get weight, yeah? Density times volume gives me weight. Agreed?
Yes, sir.
Now I can plug that value of A, yeah? So what do I get? Rho W, material property.
And weight
This L, yeah, you have
L square.
FL squared because L is already there, divided by E times delta L. Now I want to express this in two forms and you have to tell me why I am doing that, okay? So I want to write it either in this form or I want to write it in this form. Sorry. Yeah?
Sir, the second form.
Yeah, it's the same thing. Yeah, both are
So,
okay. There's nothing wrong. Here I wrote it as two factors and there I wrote it as a ratio of two quantities, yeah? Because this rho W over E it will become E over rho W when it's in the denominator. So why I am doing this? Can anyone guess? Both have the same answer.
sir,
Because we
sir,
know
because we know you have a row W.
So this whole thing is unknown. Yeah. So it means that the weight which we want to minimize, it is decided not only by E as was suggested here, but also by, tell me, also
weight
by
density.
Wait, sir.
density. Yeah, and in fact, it depends on their combination, the ratio, and you get the same ratio here, but it's in the opposite side. So there are two ways. And what about this thing? This thing? This thing? This is fixed. You can't do anything about that. You cannot change F because it's given. It's given. The requirements cannot be changed. So this highlights what an engineer can do and what he cannot do. You're not supposed to change this. You cannot tell your customer, oh, change this for me. Okay, that's your job to respect. So now, which means that I can either, if I want to minimize W, I can minimize this ratio, or I can maximize this ratio. Agreed?
Yes, sir.
And now you will now understand why I have this table. For these three materials, I have tabulated this ratio. So can anyone tell me why I have done this thing? This, why I have divided that by 10 to 6th meter? Guess?
Sir, make it easier to write.
So there are two things. One is that the unit of this thing is meter. Yeah. So I don't have to write meter here. And the values are inconvenient. So 10 to 6th will appear in everyone. So I get rid of 10 to the 6th and I get rid of meter. So I can simply write the values. Okay. Can you now tell me which material will give me the smallest possible weight?
2.724.
So the material name is steel, yeah?
Stay.
steel. So now you guess why steel is used in most of these applications, okay? Because this is real data, okay? I have not cooked it up. So let's move on to the next. Although the difference is very now because the difference is not very significant, yeah. So can you now tell me which of these three will cost less based on your experience of the market?
Aluminium, sir.
Yeah, aluminum is
Sir,
the cheapest. Aluminum is the cheapest. So if this is, as far as this particular example is concerned, you can go with aluminum, and yeah, you will not lose any significant actually strength. Okay, it can still be acceptable. Now this brings us to another topic. One thing is clear, that to avoid failure, yeah, if you want to avoid the circumstances which lead to failure, you have to make sure that the actual stress, and when I use this symbol, which stress I have in mind, tell me which type of stress I have in mind when I use sigma. You have studied two types of stresses, yeah?
So shear
Stress and normal stress, yeah? So this is for normal, okay? Normal means either tensile or compressive. So the normal strength cannot exceed the yield strength, yeah? Because yield strength, after yield strength, you know that things are not going to be fine. And similarly, the shear stress cannot be greater than, I've written greater because I want to avoid the circumstances. So the actually I need sigma to be less than that, and I need tau to be less than that. And based on experience, and this is something which only mechanical engineers can tell, because this involves some more theory. We're not covering that yet. But if you know yield strength in a diagram where you have sigma, and because you will typically have table for sigma, this epsilon, yeah, stress strain curve, and what you need for shear is this tau epsilon curve. So rather than having a new curve, it has been shown mathematically that the yield shield strength, yeah, SY, Y is for yield, S is for shield, can be calculated from yield strength for normal by simply dividing it by 2. Yeah, so you can trust that. So to make sure this is ensured, you need to define some factor of safety. It's called a factor of safety. So because you would like sigma to be smaller than SY, yeah, so you can define this ratio and you call it factor of safety for tension. Yeah, compression will automatically be covered in this. Yeah, it's a plus or minus. If tension is plus, compression is minus. So can you now tell me whether this ratio needs to be larger than 1 or smaller than 1? Tell me this ratio.
So smaller than 1?
So smaller than 1 means that you want numerator to be smaller than the denominator, yes?
Yes.
So that means that you want the yield strength to be smaller than the actual strength, the actual stress. That is
No.
failure.
Sorry, sir.
So you said the
Yes,
opposite.
sir. Sorry. It's
Yeah, it's the opposite. So both these factors must be larger than 1. Okay. Now, how large? Yeah. Some of you can say, okay, 1.2 is good enough. Some will say 1.3 is good enough. Some will say 2 is good enough. Now, this requires experience, because there are sometimes unprecedented and unpredictable failures, which nobody knows why. So to guard against those failures, engineers typically use this range. Depending on the application, it can be anything from 1.5 to 4.0. Yeah. So going above that is actually being too conservative, yeah, too conservative, and being less than 1.5 is too risky, too. Now, this choice will then depend on two things: on your knowledge. For example, if you have used a material many times, and if you know that 1.5 has worked for that, then go for that. But if you are, let's say, trying something for the first time, yeah, and you have no experience with that, then you should go for this one, yeah, depending on your experience. You get this now? And will you be able to select the right material and right stresses by using this factor of safety? Okay, so maybe you can now go back, see some of the examples, and calculate this. Maybe we have to do it in some of the problems we solve. Okay, just to see whether we are safe or not. You don't want to be on the margin. Okay, let's start with the problems now. These are end of chapter problems. Some of them were given to you as assignments, and some of them we are going to cover in this lecture. So you see this familiar handle and jaw, yeah, arrangement, this plier, but this time the geometry is different. Yeah, so let's read this. As a machinist presses the handles of the compound action bolt cutters, this is a bolt cutter, link AB, this is the link AB, yeah, from here to here, this is the link AB, carries a force of 7.5 kilonewtons. Okay, so you can write this force 7.5 kilonewtons. If the link has a rectangular cross section of these dimension, 14 millimeter by 14 millimeters. Okay, so that will give you an area. What will be the area? Cross section 14 times 4, and this will be millimeter squared. Yeah, you should not worry about that. The conversion can be done later on. Now calculate the tensile stress within it. Okay, so now we need to make sure that we are using the right area. So this is tension, this is tension, yeah. You know, when you press this downward and you press this upward, yeah, so these are the reactive forces, and this link AB will be under these forces, 7.5 kilonewton upward, 7.5 kilonewton downward. So why do you think this area is the correct area to use? What we need to check? We need to make sure that the forces, this is the force, it is perpendicular to the area. Yeah. So how do you make sure that this must not involve this length? Yeah, because that will be parallel then. So it is telling you cross section. Yeah, so it means it's the right area. So you can simply use the formula sigma for tensile stress. Yeah? Within it makes sense because it's an internal phenomena. So force divided by area, you just make this calculation, yeah? And make sure that you get rid of, if you want to report your answer, you just look at the values. Maybe you will have your answer conveniently written as megapascal or gigapascal depending on the values. So you have to get rid of milli and you have to get rid of kilo and maybe either mega or giga. That is something you can do. So that's easy. This looks tricky, but if you think carefully, it's an easy problem. So you see the structure, and part A says by using either the vector algebra or polygonal methods for finding a resultant, determine the magnitude of F. So you want to know the magnitude of F, that will cause the net effect of the three forces to act vertically. To act vertically. What does it mean? Tell me. That what must be zero here? Read this and tell me. The resultant of all these three forces must be. Sorry?
So the x components
X component must be zero. So which means that sigma Fx must be zero. So just list all the components. It will be F times cosine of what? Tell me. Remember, this is 45, yeah? So this will also be 45. Agreed?
Yes, sir.
So it's 4 cosine of 45. Okay, and this is plus because it's, let's say you have this convention, yeah? Xy. So this will be plus. And what about 410 newtons? Remember,
30.
if you make this triangle that is opposite 30 degrees, that will be sine 30, yeah? And that will be minus because it's towards the left, yeah?
Yes, sir.
And then minus 200 newtons. And the adjacent is cosine of 10, and this will be minus, and you just set this to 0, so you will calculate your F here. Okay, for that value of F, let's assume you have worked that out. Determine the stress in the bolt's 3/8 inch diameter straight shank. This is the straight shank, yeah? और बोल्ट यही है ना, ठीक है? So that is actually a cylindrical shape, and it's the cross section, yeah? So the cross sectional area definitely is, you know, pi d squared over 4, yeah? And you know that pi over 4 3/8, yeah, inch squared. You work that out. This will give you something in inch squared. Now so tell me, is this tensile stress or shear stress? Is this tensile or shear?
Sir, tensile.
Why? Because the force is vertical, yeah?
Yes, sir.
And this cross section is like this, yeah? So it's vertical. Now, why it is tensile? Why it is not compressive? Tell me. Because the resultant of these three will be upward, yeah?
Upwards.
And this nut will make sure that the reactive force is downward. So the bolt will be in a state of tension. So now you need to calculate that Fy, yeah? And that will be, because you know F, so it will be F sine of 45, yeah? Plus 410 cosine of 30 plus 200 sine of 10 degrees. You have this Fy, and your stress is Fy divided by area. Agreed? It's not always F over A, because here F is not the right force. What you have, the right force, normal force, it's normal stress. So it's Fy, not F. समझ आ गई ये बात?
Yes, sir.
So we need to move on. Now this question can misguide you if you're not careful. Okay. So we have seen shear stress. We have seen two types of stresses: normal stress. Normal में आपको पता है टेंसाइल होता है और कंप्रेसिव होता है, और shear में एक तो आपको पता है नॉर्मल और पैरेलल, लेकिन shear we associate this with cutting, yeah? With cutting and scissors, yeah. So that name can mislead you. We need to be very careful not to actually go by that name only, because every problem is different. So the first thing you need to see in this, that because you see this saw blade, yeah, and this will cut. So when this cut, okay, if you're not careful, okay, you might think this is a problem of shear stress, but we need to be careful now. So let's read the question. In a machine shop, the band saw blade, which is this thing, is cutting through a workpiece. Where is the workpiece? Yeah. So between these between two guide blocks B. So ये जो blocks B है, इनके दरमियान कोई चीज है जिसको इस ब्लेड ने जो है ना काटना है, ठीक है. Now to what tension P? Now this is tension P. अब पता है जब आप काटते हैं तो ब्लेड को आपने बिल्कुल सीधा रखना है. If this blade actually twists, then the cutting is not effective. ठीक है, आपने देखा होगा. So what tension P should the blade be? So it's a question about the blade. It's not a question about the workpiece. ये बात समझ आ रही है? There are two things here. One is the workpiece which is being cut here, and one is the blade. So the question is about the blade. If its stress, the stress in the blade, not in the workpiece, is to be 5 KSI during use. अब यहां पे मुझे बताओ ये जो 5 KSI है, किलो पाउंड्स पर स्क्वायर इंच, is this sigma or is this tau? बताएं मुझे.
So it is tensile.
Because we are not talking about the workpiece, yeah.
Yes, sir.
अगर वर्कपीस की बात होती तो उसके जब आप काटते और उसके लिए ये डायमेंशन भी गिवन होते, ये डायमेंशन गिवन होते, ये क्योंकि आप उसको काट रहे हैं, ठीक है. यहां पे ये डायमेंशन इसने दिया हुआ है कंफ्यूजन के लिए, क्योंकि इसका ये डायमेंशन भी, ये सॉरी आपको ये डायमेंशन भी चाहिए था, फिर ये पूरा डायमेंशन चाहिए था क्योंकि आपने उस वर्कपीस को काटना था. अब यहां पे इस सिग्मा के लिए एरिया कौन सा होगा, ये बताएं मुझे. नॉर्मल एरिया कौन सा होगा? एक तो ये आ रहा है ना इसमें, क्योंकि दिस इज नॉर्मल टू पी, या so 3/8 inch is normal to P. Now I must multiply this with something. What is that something? Is that 3 inch or is that this 0.025 inch? Remember this is the side view, yeah? This side view. Which of these two dimensions are perpendicular to P?
So 3 inch.
3 तो उसके पैरेलल है ना, ये y एक्सिस
0.025
ये है ना, ये क्रॉस सेक्शनल एरिया है ना, इसलिए तो आपको उसने साइड से लिखा है ना. यहाँ पे वो थिकनेस नजर ही नहीं आ रही. तो P को परपेंडिकुलर एक ये साइड हो गया और एक ये साइड हो गया, साइड व्यू. ये तो दिस 3 inch is parallel to P. ये 3 inch वहां पे चाहिए होता है जब हमें कोई वर्क पीस के बारे में shear stress अगर हम कैलकुलेट कर रहे होते हैं. So it is 0.025 inches. You multiply this, you get something an inch squared, or ये फिर you get sigma over A you will have something in KSI, ठीक है, नहीं ये तो गड़बड़ हो गई. Sigma is, sorry, P over A must be sigma, yeah, and the question is about P, so P must equal sigma times A, yeah. So you multiply these two, and when you multiply the two, you will have KSI somewhere, and you will have inch squared somewhere. Now square inch per square inch per square inch will cancel out. You'll be left with K, and the rest of the calculation you can do. Okay. अच्छा, मुझे बताएं ये इसने आखिर में ये क्यों लिखा है, ये वाला, ये because if you get into this calculation of the teeth, that will be a very complicated problem. Okay, so you just ignore that. Otherwise, to be very precise, you have to take that into account as well. So let's move on. What do you see here? You see a vehicle. It's also, because it's a small vehicle, so you must have heard this name, sedan. So the tires of 4555 pound sedan are, तो इस पहले तो हम इसका वेट नोट कर लेते हैं ना, ये जो वेट है, that's the weight. Maybe we can just call it W. Okay, 6.5 inch wide. इसमें कौन सा डायमेंशन है बताएं? What do you mean by 6.5 inch wide?
Sir, width of tire.
हाँ, तो width of tire यहाँ पे आपको डायग्राम में नजर आ रही है, यहाँ नजर आ रही है, इसमें
No, sir.
इसमें नजर आ रही है, इसमें भी नजर नहीं आ रही है. इसका मतलब ये है कि आपको इसका वो चाहिए, फ्रंट साइड व्यू चाहिए, ठीक है. इसका जब आप इसका साइड व्यू लेंगे यहाँ पे ऐसे, तो दिस इज व्हाट इज मेंट बाय 6.5 इंच. समझ आ गए? लेट्स से यू लुक एट दिस फ्रॉम दिस साइड. अच्छा, each tire contacts the ground over a distance of 4.25 inches की बात हो रही है. ये contact distance हो गया as measured along the vehicle's length. Now calculate the compressive stress between each tire and the road. Between each tire and the road. Why compressive? Compressive की बात ही क्यों कर रहा है? Tensile क्यों नहीं है? बताएं.
सर टायर प्रेस होते हैं इसलिए.
हाँ, तो प्रेस क्यों होता है? स्ट्रेच क्यों नहीं होता?
सर वेट है सर, डाउनवर्ड
हाँ, तो वेट डाउनवर्ड है और ये टायर है, ठीक है. तो वेट डाउनवर्ड है और ये जो रिएक्शन फोर्स है रोड का वो भी उसका अपोजिट है. सो टायर विल ऑलवेज बी इन अ स्टेट ऑफ कंप्रेशन, ठीक है. एक्सटर्नल फोर्सेस विल डिटरमिन वेदर विद सिस्टम. आपने ये नहीं कहना कि ये टायर है और ये कार है और ये कांटेक्ट हो रहा है इसका. सो ओके, between each tire and the road, the location of vehicles mass center, ये given है यहाँ पे, ये बड़ा important है, location given है, ये mass center है. तो आप जो assume अगर आप कर रहे हैं कि नहीं ये mid में है 50 inch plus 50 inch, तो वो गलत है, ये 40 inch from this tire है, ठीक है. And you assume that okay, this distance and this distance is the same, या आप assume ना भी करें, it doesn't matter, ठीक है. And the wheel base dimensions are shown. अच्छा, तो अब हम यहाँ पे the question is how is this total weight distributed among the 4 tires? आपके पास कितने टायर्स हैं? 4, ठीक है. उन 4 में ये कितना वो होगा? Your first guess will be that it's W over 4, W over 4, W over 4, W over 4. Why is this dangerous? ये कब ठीक होता बताएं?
सर जब फ्रंट टायर और जो मास सेंटर है उसमें डिस्टेंस मतलब सेम
अगर ये
होता है।
अगर ये मास सेंटर यहाँ पे होता ना, ये मिडवे होता 50 इधर और 50 इधर, फिर आप ये एज्यूम कर सकते थे। अब यहाँ पे वो एज्यूम नहीं कर सकते आप, ठीक है? सो इसका हल कहाँ से निकालेंगे?
सर 60% पीछे होगा W का और 40%।
हाँ, तो उसका तरीका क्या है ना, वो कि मतलब उसका आपको पता है एक फोर्स बैलेंस होता है और एक यहाँ पे we need force balance and we also need moment balance, yeah, balance of moment. So the best thing is to draw a free body diagram. We have been doing that. So let's say you have 1 point for the 2 front tires, yeah, agreed? 1 point for the 2 front tires, 1 point for the 2 back tires, और ये आपका क्या हो गया? ये सेंटर हो गया. Let's call this C, let's call this A, and let's call this B. And this distance, you know, yeah, this distance is
40.
and this one is 60 inch, yeah. अब मुझे बताएं कि इस सेंटर पे कौन सा एक्सटर्नल फोर्स लग रहा है? This one, yeah.
Wait.
And I'm showing it here because this is done by Earth, yeah. Earth is the external body, so rather than showing it this way, it makes more sense. Although mathematically it's the same thing, so I'm just writing this W, which is 4,555 pounds. और यहाँ पे रिएक्शन फोर्स चूंकि ग्राउंड से आ रहा है, तो this one and this one. Let's call this R1 and let's call this R2. Now, because there are 2 tires, so if each one has R1, then this will be 2R1, agreed?
Yes, sir.
And this will be, that will make your calculation easy, okay? Now, what are the unknowns here? R1 and
R1
R2.
and 2.
Yeah. And remember, what is the question? You want to do it for each tire, yeah? Between?
Yes, sir.
So इसका मतलब ये है कि अब आपने इन दो की कैलकुलेशन अलग करनी है, इन दो की आपने अलग करनी है. हम एक के लिए करते हैं, दूसरा आप खुद कर लेंगे, ठीक है? So let's say we want it for R1. तो R1 कैलकुलेट करने के लिए we can take the pivot, we can take B as our pivot, yeah, and write an equation for moments. So sigma moments must be 0, yeah, about B. Agreed?
Yes, sir.
तो बताएं क्या क्या, और आप अपना वो चूज कर लेना x y, और let's say this is positive. So twice R1 times, yeah, 100 inch and 4,555 pounds times, this will multiply 60 inch. You can set this to 0, and one of them is a plus and one of them is a minus. Which of them is a plus?
455 LB.
Yeah, because that's counterclockwise and this is clockwise. This will give you a value for R1. ठीक है? अब हमारा क्वेश्चन R1 का नहीं है, हमारा क्वेश्चन किसका है? स्ट्रेस का है. So let's call that sigma 1. Yeah, sigma 1 means sigma 1 will be the stress in each of the front tires. Yeah, दोनों में sigma 1, एक में भी sigma 1, दूसरे में भी sigma 1. So sigma 1 के लिए मैं क्या कर सकता हूं? I can write here Can I write R1 now? Because R1 is the force acting on one of the tires, yeah? और यहाँ पे क्या होगा?
Area.
Area. So let's call that area A1, yeah? So now you have calculated A1, now I need to know A1. A1 के लिए मुझे क्या क्या चाहिए?
Sir, width or the dimension जो मतलब
Radius,
contact पे
diameter.
Contact ये, क्योंकि यहाँ पे ये हो रहा है ना, कंप्रेस हो रहा है. कॉन्टेक्ट ये है और इसका जो विड्थ भी है, इसका ये हाइट कहीं नहीं आ रहा, ठीक है. So now we need to multiply 4.25 inches and 6.5 inches. You multiply this, and now you know R1, you know A1, you get sigma 1. ठीक है. और यही कैलकुलेशन आप R1 R2 के लिए भी कर ले. Maybe you don't need to write a moment equation for R2 because you know R1 plus R2. In fact, 2R1 plus R2 must be equal to W. Yeah? You can use force balance to simplify that calculation. This will give you R2. Now this is a question where both of the concepts are required. You need to understand those statics as well, yeah, force balance, moment balance, but you also need to understand materials and stress and strain and things like that. So this is a problem involving two domains, statics and materials. This is another straightforward problem. The steel bolt, this is the steel bolt, and anchor assembly is used to reinforce the roof of a passageway in an underground coal mine. अब ये details हैं. In installation, the bolt is tensioned to 5,000 pounds. तो अब यहाँ पे अगर आप tensile force show करना चाहते हैं तो आप you can write it P and P, yeah, and you can write P equals 5,000 pounds. Cross section given है. Calculate the stress, strain and extension of the bolt if it is formed from this steel alloy. अब यहाँ पे मटेरियल पे बाद में आ जाते हैं. एरिया क्योंकि सिंपल टेंसाइल स्ट्रेस है तो इसका एरिया जो है ना π/4 और ये 5/8 इंच हो जाएगा एंड स्क्वायर्ड है. इस 34 इंच का यहाँ पे कोई रोल नहीं है क्योंकि दैट्स द लेंथ. नाउ द क्वेश्चन इज these two can be combined to give you stress, yeah, no problem. Stress is P/A. Done. The question is strain, yeah. When you need to find the strain के लिए आपको फिर चाहिए E, yeah. So it will be sigma divided by E. Now अब इस इक्वेशन को लिखते हुए हमने क्या assume किया है, बताएं क्या assumption है इधर. इस क्वेश्चन में ऐसा कुछ नहीं है. तो आप assume कर रहे हैं कि it is away from failure, away from failure कब होता है, जब ये yield strength से भी कम हो, and most likely you will assume that proportionality, yeah, क्योंकि उसके बाद आपको पता है चीजें खराब होना शुरू हो जाती है. अब यहाँ पे क्या अननोन है इस इक्वेशन में? This sigma comes from there and E has to come from some table. और वो टेबल किसका होगा? 1045 steel alloy. Let's read that. I have one table here and you see this alloy here, yeah, 1045, yeah, steel alloy. लेकिन यहाँ पे कौन सा स्ट्रेंथ दिया हुआ है? अल्टीमेट स्ट्रेंथ, या
Yes, sir.
एंड यील्ड स्ट्रेंथ. आपने इन दोनों के करीब नहीं जाना, क्योंकि फैक्टर ऑफ सेफ्टी रिक्वायर्स व्हाट, दैट यू नीड टू स्टे अवे फ्रॉम यील्ड स्ट्रेंथ. अल्टीमेट स्ट्रेंथ से तो दूर रहना ही रहना, यील्ड स्ट्रेंथ से भी दूर रहना है. सो इसका मतलब ये है कि ये गलत टेबल हम देख रहे हैं. ठीक है, एग्रीड?
Yes, sir.
तो हम कौन सा टेबल देखेंगे? हम
मटेरियल प्रॉपर्टी.
मटेरियल प्रॉपर्टी तो वो भी थी, सॉरी, ये भी मटेरियल प्रॉपर्टी है, लेकिन वहां पे मॉडुलस इलास्टिक मॉडुलस दिया हुआ है.
Modulus वाला.
अच्छा, लेकिन इंटरेस्टिंगली वहां पे सिर्फ ये लिखा हुआ है. अब इसका क्या मतलब है कि ऑल द स्टील ऑला, ये उन सब का ये ई सेम होता है, एटलीस्ट दोज विच आर यूज्ड इन द मार्केट. सो अब यू डोंट केयर कि वो 1045 है, क्योंकि उनमें जो फर्क है वो दूसरे टेबल में है, इस टेबल में नहीं है. ये समझ आ गई बात? ये जो इनमें फर्क है ये सिर्फ इनके इस प्रॉपर्टी में है. ई इज द सेम, सो आप जस्ट वही यूज करो स्टील एलाइज की दिया हुआ है. वो क्या है? इधर 30 मेगा psi और 207 गीगा पास्कल, डिपेंडिंग कि आपको यूनिट्स कौन से गिवन है. आपको चूंकि पाउंड गिवन है, so you will pick 30 mpsi. 30 mpsi. So E in our case is 30 mega psi. ठीक है? It's just a coincidence that you don't have MSI, although you have KSI, but there is no MSI. For that you need to write MPSI. So you just plug this and deal with the units and you can find out the strength. अब stress भी पता चल गया, strain भी पता चल गया. The rest is the extension. Extension आपको पता है वो कहाँ से कैलकुलेट करनी है. डेल्टा L equals strain times L. strain आपने यहाँ से कैलकुलेट किया और L आपको अब समझ आ गया कि ये 34 इंच आपको यहाँ पे हेल्प करेगा. This will be used in this calculation. ठीक हो गया?
Yes, sir.
So let's move on to the next question. Here you see 600-pound force, and it acts on the vertical plane. Yeah. So this is your tensile force. I don't know if it's tensile or not. It is tensile for this sheet, of course. Yeah, but maybe it's not tensile for the bolts. How many bolts do you see in this picture?
5.
5 bolts, and this is the side view. This is your side view. Yeah. Acha, and in each of those 5 bolts, because the bolt is preventing these two pieces to slide against one another, so there is a single shear plane in each one of them. Yeah. तो कितने shear planes हो गए यहाँ पे total?
5.
5 planes. Yeah, because each bolt will give you one plane. तो 2 का फार्मूला हर पे नहीं लगता, लेकिन ओवरऑल बिकॉज देयर आर शेयर. ना अब ये इसलिए जरूरी है कि दिस 600 पाउंड्स will be shared between these 5 bolts. समझ आ गई बात? They all will have to deal with this combined together. So which in turn is connected to the horizontal stress, ये आपका horizontal stress है, by 5 316-inch diameter rivets. तो हर रिवेट, इसको रिवेट कहते हैं. बोल्ट शायद इसको कहते हैं जिसमें आप जो है ना वो नट वगैरह लगा सकते हैं. ये मैन्युफैक्चर्ड होता है, तो इसको इसलिए रिवेट कहते हैं. सो हर रिवेट का डायमीटर कितना है? 316 इंच, और कितने हैं? 5 हैं. नाउ इफ द रिवेट्स शेयर द लोड इक्वली, सो जस्ट अस्यूम दैट द लोड इज शेयर्ड इक्वली. तो हर रिवेट में कितना shear फोर्स होगा बताएं आप?
600 divided by 5.
So 600 divided by 5 pounds will be your shear force. shear force के लिए आपको पता है हम V symbol यूज करते हैं. ठीक है. Determine the shear stress in them. ठीक है ना। एंड देम का मतलब है कि ईच वन ऑफ देम। अब पता है ना, स्ट्रेस ऐड नहीं होता, आप ये नहीं करते कि सिग्मा 1 प्लस सिग्मा 2 और टाउ 1 प्लस टाउ 2, आप ये क्यों नहीं करते बताएं, ये क्यों नहीं करते आप? क्योंकि स्ट्रेस इज डिफाइंड एट ए पॉइंट, ये डिस्ट्रीब्यूटेड फोर्स है ना। फोर्स आप ऐड करते हैं F इज इक्वल टू F1 प्लस F2, लेकिन आप स्ट्रेस को ऐड नहीं करते, स्ट्रेस में एक पॉइंट पे होता है, ठीक है।
स्ट्रेस से टोटल होता है एक ही।
हाँ, लेकिन वो उस पॉइंट जो आपने स्ट्रेस बता दिया, मैं सिर्फ ये कह रहा हूँ ना कि एक लेट से आपके पास ये 5 बोल्ट्स है ना, 5 बोल्ट्स हैं, तो इसका स्ट्रेस आपको पता चल गया, लेट से टाउ 1 है, इसका टाउ 2 है, इसका टाउ 3 है, इसका टाउ 4 है, इसका टाउ 5 है। सो दिस सम टाउ 1 प्लस टाउ 2, दिस डजंट मेक एनी सेंस। क्यों? क्योंकि स्ट्रेस तो हर पॉइंट पे डिफाइंड होता है ना, तो आप ये स्ट्रेस इस स्ट्रेस के साथ कभी भी ऐड नहीं करेंगे, समझ आ गई?
यस सर।
लेकिन अगर ये फोर्सेस होते, लेट से एक फोर्स इधर है F1 और एक फोर्स इधर है F2, तो यहाँ पे कोई सेंटर लेके आप ये कह सकते हैं कि इन दोनों का कंबाइंड फोर्स यहाँ पे F1 प्लस F2 है, ये आप कर सकते हैं, ठीक है। इसका इस आपने वही बात, आपने EMT नहीं पढ़ा ना, EMT तो नहीं पढ़ा, लेकिन फिजिक्स तो आपने पढ़ा होगा ना। फिजिक्स में आपको पता है इलेक्ट्रिकल फोर्स होता है एक, तो वो आप ऐड कर सकते हैं, लेकिन जो इलेक्ट्रिक फील्ड स्ट्रेंथ है ना, इफ यू रिमेंबर दैट थिंग, इलेक्ट्रिक फील्ड स्ट्रेंथ, वो आप कभी भी ऐड नहीं करते, क्योंकि दैट इज समथिंग डिफाइंड एट अ पॉइंट। Okay, so we know that in part A, the shear force is 600 divided by 5 pounds. That makes it कितना हो गया ये? 120 pounds. And the area of each rivet for calculation, यहाँ पे कौन सा एरिया होगा बताएं? पैरेलल होगा,
सर
जो पैरेलल होगा ना ये,
यस।
तो इसका क्रॉस सेक्शन वो चूंकि बोल्ट ऐसा ही है, ये साइड व्यू है आपका ना, तो इट विल बी उसका डायमीटर ही आएगा पाई बाय 4 3/16 इंच स्क्वायर्ड, ठीक हो गया, यहाँ पे कोई कंफ्यूजन नहीं है। सो द स्ट्रेस टाउ इन ईच ऑफ दोस 5 बोल्ट्स will be V over A and you make that calculation. Part B में इसने क्या किया हुआ है, ये जरा इंटरेस्टिंग क्वेश्चन है। In a worst case scenario, 4 of the rivets have corroded, वो corrode हो गए हैं, इसका मतलब they are no longer able to support this load. So the load is now carried only by one rivet, क्योंकि जब वो है ही नहीं, वो corrode हो गए, वो तो support नहीं करेंगे ना। Then what is the shear stress in this case? तो बताओ यहाँ पे क्या होगा, V क्या होगा इसमें?
600।
V will be 600 pound because there is only one shear, or T tau is equal to V over A, so change हो जाएगा। अगर let's make sure that you understand what I'm trying to say. Let's say मुझे रिवेट, ये क्वेश्चन जिस तरह आपको याद है ना, जिस तरह पहले एक क्वेश्चन था, ये क्वेश्चन इट वाज नॉट अ क्वेश्चन अबाउट द वर्क पीस, बट इट वाज अ क्वेश्चन अबाउट द सॉ या द ब्लेड। तो यहाँ पे what if the question was not about the rivets, but it was a question about the plate, the vertical plate, या vertical plate ये है ये, तो इस vertical plate में कौन सा स्ट्रेस रेलेवेंट होता फिर बताएं?
टेंसाइल।
और उसके लिए कौन सा एरिया हमें चाहिए होता था, उसके लिए क्या क्या डायमेंशंस चाहिए? फर्स्ट वी वुड नीड दिस
तो
डायमेंशन,
वेट।
दिस विड्थ,
यस सर।
और इसका जो साइड व्यू पे थिकनेस है वो भी हमें चाहिए होता था, ये जो थिकनेस है, ठीक है। नाउ यू शुड अंडरस्टैंड व्हाई वी सॉल्व दैट प्रॉब्लम डिफरेंटली, क्योंकि वहां पे दैट वाज अ क्वेश्चन अबाउट द प्लेट। नाउ द नेक्स्ट क्वेश्चन is something which you have covered in chapter 4, and we solved that problem. आपको याद होगा ये एक क्वेश्चन था जिसमें you had 3 cables, yeah, or although only one angle was given, but when we made the calculation it turned out that all these angles were equal, 60 degrees, 60 degrees, 60 degrees. I remember that question, yeah. तो उसका or this force, sorry, this upward force was balanced by these two forces and all of them were the same. So that force was 800 pounds. This was also 800 pounds and this was also 800 pounds. You remember that question?
सर 120 डिग्री नहीं होगा?
हाँ?
सर 120 डिग्री नहीं था?
सॉरी ये मैंने गलत कर दिया, ये ठीक है, ये बात ठीक है। वो 60 डिग्री मेरे ख्याल में उसमें था जब उसने ट्रायंगल हमने बनाया था ना।
यस सर, जब
ट्रायंगल बनाया था, ये 120 है, आपकी बात बिल्कुल ठीक है। वो हमने असल में एक ट्रायंगल बनाया था फोर्सेस का, तो ये 60 था, ठीक है, आई मिस दैट आउट। बट एनीवे, one thing is clear that each of these cables, they are under tension of 800 pounds, ठीक है, the tension in each cable. अब question क्या है कि now you zoom this shackle, yeah, ठीक है। इससे वैसे मैं एक और बात मुझे याद आ गई, I don't know if you have people from, let's say, the 20th century, including myself. तो यहाँ पे एक वर्ड आपने देखा होगा एक क्वेश्चन में, कौन सा था वो? Have you heard this word before? This?
Yes sir.
Shank, ठीक है ना? So ये shank असल में यहाँ पे इसका एक मतलब है, लेकिन जो आपका बाथरूम में जो सिंक होता है ना, वो सिंक के साथ भी ये shank होता है। और मेरे I even remember there is a company called Shank and they were actually making these sinks. So there are many people from that period and they call it Shank. Yeah. So this is a thing, I remember it that way. So if you zoom this, now you understand what is, we didn't discuss it then. At that time, it was a question of statics, yeah? उस टाइम पे ये मटेरियल हम नहीं पढ़ रहे थे, we were not worried about how this thing is supporting it. लेकिन now you zoom it and now you see, oh okay, it is this bolt which is actually doing the job, yeah? तो यहाँ पे nuts हैं, एक bolt है, और it turns out that this is actually a problem of shear stress, ठीक है, क्योंकि this, although it's a tensile stress for the cable, but for this bolt it's shear stress, agreed? Because this cable is going to break this, it's trying to break or cut this this bolt. तो bolt के लिए कौन सा stress हो गया? shear. और cable के लिए क्या हो गया? tensile. Question किसका है? ये shear stress ना भी होता ना, ये word यहाँ पे. So because the question is about the bolt, you should be clever enough to figure out that is the shear stress. Bolt के लिए shear stress होगा और केबल के लिए tensile stress होगा। समझ आ गई ये बात आपको?
Yes, sir.
Okay, so now tell me how to solve this problem. What is the shear stress? Tau equals cross-sectional area of the bolt and the shear force. तो shear force कितना है? Hmm?
800.
Okay, it's the same. It's the same for each cable, yeah. जो टेंसाइल फोर्स है उसके लिए वही यहाँ पे, लेकिन नहीं, एक मिनट, गड़बड़ हो गई ना यहाँ पे, गड़बड़ हो गई यहाँ पे, क्योंकि यहाँ पे आपको प्लेन्स कितने नजर आ रहे हैं? ये तो हमने देखा ही नहीं है। कितने प्लेन्स यहाँ पे जो कट हो रहे हैं? एक इधर है और एक, ये दोनों कट होंगे ना?
Yes, sir.
So actually 2V equals 800 pounds. This 800 pounds will be shared with this plane by this plane and this plane. ये हमने इस तरह के एग्जांपल पहले भी किए हुए हैं. तो V will be equal to 400 pounds. ठीक है? This is tricky and you can miss it very easily. So it's 400 pounds, or area, you know, pi over 4 3/8 inch squared. ठीक है? Do you remember this thing? कि हमें ये 2 क्यों चाहिए? क्योंकि this is not the first time we are doing it, yeah? The last question in this chapter. You have a plastic pipe, yeah? So this is the plastic pipe. It carries deionized water in a microelectronics clean room. ठीक है? Microelectronics clean room में जो है ना deionized water carry करने के लिए you have a plastic pipe. ठीक है? And on one end of it is capped. तो कैप कहाँ पे लगा हुआ है? ये वाला. इस कैप की बात हो रही है, इस साइड पे. दूसरी साइड पे खुला है पानी के लिए. And this is the side view. ठीक है? यहाँ पे can you tell me before I move on, can you tell me इसने यहाँ पे ये डायग्राम क्यों शो किया हुआ है? यहाँ पे आपको क्या सिंबल नजर आ रहा है? टाउ. टाउ किसका सिंबल है?
shear stress.
तो shear stress यहाँ पे क्यों होगा, मुझे बताएं. ये डायग्राम देख के बताएं. इस कैप को छोड़ दें, कैप कंफ्यूज कर रहा है आपको. This fluid, yeah, is going to flow, yeah, either this way or this way. Agreed?
Yes, sir.
So when it is flowing, it will flow past this, the wall of the pipe, yeah, and this wall of the pipe. Agreed?
Yes, sir.
Okay. So, but I think one thing is clear, that this is not a problem of fluid. So maybe I'm getting too far. This seems to be a much simpler problem. Because of this fluid flowing, let's say in this direction, this fluid will hit this cap, and when the fluid hits the cap, what will this cap feel? It will feel a force, yeah, and that force is distributed, yeah. Distribute का मतलब है कि पूरा जो surface है वो उसको feel कर रहा है. So maybe at the intensity of that force at a point can be quantified by the pressure, by the pressure. ये बात तो आपको समझ आ गई ना कि when you have too many forces acting on the same surface, rather than adding the forces, maybe you can say, okay, at any point the intensity of the force is what I mean by pressure. ठीक है? तो वो pressure fluid की वजह से यहाँ पे कितना है? 50 psi. Now this force from the fluid is perpendicular to this area. This is something you need to note. लेकिन यहाँ पे आपको ये क्या नजर आ रहा है? ये जो इसने ब्लैक शो किया हुआ है, ये क्या है? ये
So contact.
ये इसको एडहेसिव्स कहते हैं ना, बाइंडिंग एडहेसिव. ठीक है? क्योंकि अगर ये ना होता तो इस प्रेशर की वजह से क्या होता, ये कैप कहाँ निकल जाता, ये इधर निकल आता ना. So this cap is actually bound to this pipe by this adhesive material. So adhesive material के against कौन सा stress होगा, वो कौन सा होगा? अब आपको समझ आएगा ठीक क्यों उसने किया हुआ है. Just listen to the reasoning again. The flow of the pipe will apply a force on this cap with generated by the pressure. By the way, वो force कितना होगा मुझे ये बताएं. How do you calculate the force arising from a pressure? पता है आपको?
P over A.
P over A नहीं, P times A.
Yes, sir.
F over A is P. ये कौन सा एरिया होगा मुझे बताएं. Let's call this area A naught. ये कौन सा एरिया होगा जो इसका
कैप होगा,
ये वाला जो इसके सामने एरिया है ना, इसका कैप का एरिया, तो वो कितना है? जस्ट राइट 50 psi टाइम्स, बताएं कितना एरिया होगा ये. कौन सा डायमीटर हम यूज करेंगे? तो पाई ओवर 4 0.75 inch squared. Agreed? This will give me the force. और ये मुझे फोर्स पाउंड्स में मिल जाएगा. ठीक है, आफ्टर आई डील विद द यूनिट्स. लेकिन यही फोर्स, दिस फोर्स इज ए कंप्रेसिव फोर्स. इट्स अ कंप्रेसिव फोर्स फॉर द कैप. एग्रीड? कैप को कंप्रेस करेगा. लेकिन एडहेसिव के लिए कौन सा फोर्स है? फॉर द एडहेसिव, एडहेसिव के लिए ये फोर्स कितना है? कौन सा फोर्स है? shear force. Agreed?
Yes, sir.
तो अब बताएं कि आपके पास कितने shear planes हैं?
2.
2 shear planes हैं. सोच लें, ये डायग्राम आपको मिसगाइड कर रहा है.
सर एक ही.
असल में ये एक रिंग बना हुआ है ना, रिंग नहीं होता, क्योंकि ये तो ऐसे ही आया हुआ है ना, ये मतलब इसको अगर आप साइड से देखें तो ये रिंग नजर आएगा इस तरह. तो इट्स अ काइंड ऑफ ए सर्कुलर प्लेन, तो इसको नहीं कह सकते, लेकिन वो जो सरफेस है जिसके ऊपर आपने कैलकुलेट करना है, इट्स अ रिंग, और उसका एरिया आप कैलकुलेट कर सकते हैं, आप उसको प्लेन कहें या ना कहें. ये बात समझ आ गई है?
Yes, sir.
तो वो एरिया कितना है आप मुझे बताएं. वो
0.5 inch.
आप रिंग का एरिया कैसे कैलकुलेट करते हैं?
सर पाई इंटू
इसको ना, इस
0.
रिंग को आप स्ट्रेट करें ना. कैन यू मेक इट स्ट्रेट? इसको आप लेट से ओपन कर दें, तो उसका ये लेंथ कितना होगा? यू कैनॉट चेंज द एरिया बाय स्ट्रेटनिंग. मैं आपको कोई सर्कुलर रिंग दे दूं और आप उसको बिल्कुल खोल दे, तो उसका लेंथ कितना होगा? पाई टाइम्स द डायमीटर. या
D square.
नहीं, पाई डी.
Pi D.
2 पाई
ठीक है,
तो
ठीक.
पाई डी हो गया ना, पाई टाइम्स डी. 2 पाई आर
2
इज
पाई आर. यस, 2 पाई आर 2 पाई डी हो गया सर.
पाई डी हो गया ना, और डी वही डी है ना. ठीक है, so it will be pi times 0.75 inch. और इसका ये कितना होगा ये साइड?
ये सर वही होगा जो रिंग का पहले था.
ये पैरेलल ये है ना, समझ आ गई? ये इसका ये लेंथ, जब आप इसको स्ट्रेट करेंगे तो ये 0.5 इंच तो कहीं नहीं जा रहा ना. एग्रीड? क्योंकि ये
Yes,
एरिया
sir.
पैरेलल है ना. आई एम नॉट टॉकिंग अबाउट द थिकनेस ऑफ द एडहेसिव. सो A is basically 0.5 inch times pi times 0.75 inch. अब आपको समझ आ रही है ना कि ये एरिया क्यों डिफरेंट है और ये एरिया क्यों डिफरेंट था? क्योंकि दिस एरिया वाज नॉर्मल टू द फोर्स, इसलिए हमने उसको मल्टीप्लाई करने के लिए ये वाला एरिया कैलकुलेट किया, यहाँ पे हमने ये वाला एरिया कैलकुलेट किया. अब मुझे बताओ कि मुझे अब वो 2 टाइम्स v की जरूरत ही नहीं है, क्योंकि मुझे सारा एरिया मिल गया, और उस पूरे एरिया में फोर्स कितना है? दैट सेम फोर्स, क्योंकि ये फोर्स सब पे अप्लाई हो रहा है ना, ये पूरे एरिया पे अप्लाई हो रहा है. So now my shear stress is that same F divided by A, which is P naught A naught divided by A. अब समझ आ रही है आपको?
Sure.
ठीक है, so two areas, one for the cap to calculate the force from pressure and the area of the ring of the adhesive. और यहाँ पे वो 2 और 3 और 5 की जरूरत इसलिए नहीं है कि इट्स द सेम रिंग, और वो जितना भी फोर्स है ना, क्योंकि आपने बेसिकली यहाँ पे मैं क्यों वो 2 टाइम्स और 5 टाइम्स की बात नहीं कर रहा, आपने इस एरिया से मल्टीप्लाई करके क्या किया है, बेसिकली यू हैव एडेड ऑल द फोर्सेस, जितने भी फोर्सेस है ना जो इस रिंग पे आ रहे हैं, आपने सबको ऐड कर दिया. This area is actually playing the role of that factor. Normally आप 2 टाइम्स करते थे, 3 टाइम्स या 5 टाइम्स करते थे वो बोल्ड रिवेट के केस में. So we are done with this chapter now. If you have questions, we have some time left for the questions. 5 minutes.